Hello everyone, welcome back to today's online class of class 9 physics, and today we will be continuing on our chapter that is gravitation, chapter number 10. So in this chapter till now we have learned about the universal law of gravitation, which was given by Sir Isaac Newton, in which he told that the force between two bodies, that means the force of attraction between two bodies, is given by the product of the masses divided by the square of distance between them. And to remove the proportional, we use capital G. That was the formula we learned previously in the previous video. Now today we'll see the importance of the laws of gravitation. First of all, the gravitational force binds us to the earth. If there was no gravitational force, we had been flying onto the universe. Even if someone has just jumped a little bit, the person would have gone into the space. The motion of the moon and the other planets all are maintained by the gravitational field. Then the motion of planets around the sun, asteroids, meteors, etc. are maintained, or these all are basically because these all are moving around the sun because of the gravitational field. And also, most importantly, tides. These tides also occur due to the gravitational pull of the moon onto the earth. The gravitational pull of the moon pulls the water bodies above from the earth, and again the earth's gravitational force pulls the water down, due to which it creates the ripple effect or the tides. Today we'll learn the new topic, another topic, that is free fall. Free fall means falling freely to the ground. Like if there is an object, any object at a certain height, if the object falls from that height directly towards the ground, that is known as a free fall. In free fall, it does not depend how the object is falling, but the object should fall down due to the earth's gravitational pull. Means we should not be putting any extra force to push the object down or to make the object fall. Like if I am throwing this chalk or if I am dropping this chalk, it should fall automatically down. I should not put any force or throw it like this so that it can go down or any other way. So this is our universal law. This is known as a free fall. So in free fall, the object, as I told, the object falls directly to the ground. So free fall is related to the gravity of the earth. Free fall is related to the gravity as well as the mass of the object. The mass of the object lets the object fall in different speed. If the mass of the object is more, then the object will fall in a little bit faster way, and if the object is very lighter, like a leaf or like a feather, then it will fall down slowly. But eventually the object will come down to the earth's surface. So we'll see how this works. So as we know, gravitational force is given by capital G and small f by d square. So this is the formula that we know or that we have learned. Now we know force is given by mass into acceleration. So here we can substitute force by ma equal to g m by d square. Now we know m is the mass of the body and a is the acceleration. Now acceleration, we need to concentrate or know about the proper acceleration. When an object is falling down, it is coming at a certain speed. Now when the object is not thrown, means no extra force is given, then the object comes down due to the earth's gravity, means the object falls down because of the gravity. So this coming down motion of the object is mainly because of the Earth's gravity, if we are not applying any extra force. So in that case, the acceleration is because of the gravity of the Earth, and this is given by small g, and this g is known as acceleration due to gravity. So here in this case it becomes mg, means the acceleration means a changes to g because the object is under a free fall, and in this case there is no extra acceleration given or provided to the body. So here we will just substitute a with g. This will become g and with a small m by b square. Since this m and this m are same component, we can cancel them out, and finally we get the formula g equal to capital G into mass by d square. Now d is the distance between the two bodies. This is our formula for small g. Now if we consider the case of our Earth, for example, this is our Earth, this is the center, and here is an object. For example, there is a building, means I have drawn it small as compared to our Earth, and if something falls from a certain height, it is coming down to the surface, the object will fall down. So in this case, like for example, this is the body from where an object is having free fall and it is coming down to the ground. That means the object is falling at this level. Now we have to find out the distance. We need the distance between the two objects, two bodies. So in this case, this is the distance from here up to here, because we know we are taking the distance from using the center of the object. We take the distance between the two centers of the object. So if one object is on the ground, the other means that center will be into the object, and the other center will be the Earth's center. This is our B. And eventually, if we see properly, this is actually the radius of our Earth. So here, this B changes to G equal to M by R square, where D equal to capital R equal to, this is the radius of Earth. So this is how the formula changes. And after using appropriate values for G, capital G, the mass of the Earth and the radius of the Earth, the value of small g comes as 9.8 meters per second square. This is the acceleration due to gravity, or the value of g for our Earth, for any object on our Earth. Now this value may differ. Sometimes this value is 9.8 and sometimes this value can be 10 or sometimes like 9.6 according to the situation, because the topography of our Earth is not given. Somewhere there are mountains, hills, and somewhere there is it's plain, normal plain areas. So in this case the value of g may change. So in questions, if this is not given, means if the value of g is not provided, you have to use 9.8, and if it is given in the question, you have to use whatever value of g is provided in the question. You can write it down. Now, because of free fall, because of free fall, this some of the values may change. Like we know the three equations of motion: v equal to ut, sorry, u plus at, v equal to u plus at, then s equal to ut plus half at square and v square minus u square equal to 2as. Now if we are finding motion of any object with relative to the earth, means under free fall or something like that, means basically under free fall, in that case, in these formulas, all these values of a, all these acceleration terms will change to g. Means instead of a, we have to take the value of g. So in this case, this is v, this first formula will become v equal to u plus gt, second will become s equal to ut plus half gt square, and the third v square minus u square equal to 2gs. That means all the accelerations, all the a will change to g. This is how the formulas will or may change. Thank you.